Hi guys. Okay, here's 1.6 of our notes. So this is the last page in your Unit 1 note packet. So we are almost finished with Unit 1. Excuse me. Okay, so polygon. It's a plane figure. It's two-dimensional. That's comprised of segments and angles. The segments are defined as the polygon sides, and the points at which the two sides meet are called the vertices. So something that is a polygon. This is a polygon. This is a polygon. This is not a polygon. And the reason that's not a polygon is that this top is not a segment. It is rounded, which is not considered a segment. So it has to be all segments, no rounded sides. So a circle is actually not a polygon. Naming polygons. So a three-sided figure is called a triangle. 4 is not called a square, nor is it called a rectangle. It's called a quadrilateral. 5-side is a pentagon. 6 is hexagon. And yes, you do need to remember these. 7 is heptagon or septagon. 8 is octagon. Hopefully I'm spelling all those right. 9 is nonagon. 10 is decagon, like a decade. 11 is undecagon. 12 is a dodecagon. Do means 2. And anything larger than that is an n-gon, meaning like if it's 20 sides, it's a 20-gon. Or if it's 100 sides, it's a 100-gon. Okay? Diagonal. A diagonal of a polygon is a segment connecting two non-consecutive vertices. So if I have a quadrilateral, here's a vertice, so I can draw a diagonal there. This is not a vertice. So from this vertice, or this is not a diagonal from here to here, because that's the side of the quadrilateral, and those two vertices are connected, or they're consecutive. So that would not be considered diagonal. That's considered a side or a segment. This is a diagonal. They're non-consecutive vertices. Convex is a polygon in which each diagonal passes through the interior. So this is a convex figure. This would be considered convex because any diagonal I make in here would go on the inside. Then you have opposite that, which is concave. Concave caves in like a cave at some point. And the reason that that is not convex is because that I have at least one diagonal that's in the exterior. So this vertice and this vertice are non-consecutive. So if I connect those by their diagonal, you'll see that it's on the outside of the figure. So one way to tell a concave figure is that at least one of its diagonals go through the exterior. Equilateral polygon is a polygon with all sides equal. So the one that we think of the most would be a square. To show that, I have to put one tick mark in all sides. Or if there's a triangle that's equilateral, maybe this side is equal to this side, which is equal to this side, and I put the same number of tick marks in each side. So 2 in each of the sides, showing that they're equal. Equiangular means all angles are equal. So I show that by putting an arc in each corner. Maybe I have an equiangular triangle. That would be 60 degrees each because there's 180 degrees in a triangle. Divide that by 3 is 60 each. Maybe I put 2 arcs in each of these just to show that those 2 or those 3 corners are all congruent in equal measure. Regular polygon would be a polygon that's equilateral and equiangular, so all sides are equal and all angles are equal. The most common one, again, would be our square, because we know all angles in a square are equal. They're 90 degrees, and then we know all angles or sides are equal also. So that would be considered regular. Okay, go to the next slide. What I want you to do is I want you to pause me, and I want you to see if you can figure out the values for x and y. Knowing that this polygon is regular, so we just talked about how a regular polygon has all equal sides and all equal angles. So go ahead and pause me and try that one. And then unpause me when you're finished and we can go over it together. Okay, I am going to start with my y value because I know that this angle equals this angle, which equals this, and this. So since this angle equals that, I just set them equal to one another. So 4y minus 8 equals 108. So I'm going to start solving that. I add 8 to both sides, so I get 4y equals 188. I divide by 4. Y equals 4, carry the 2, 47 degrees. Right? Yep. Okay. So they could have asked us, well, we know that that's 108, so even if we plugged it back in, we'd find that. The other way, or the other variable is x. All sides are also equal because it is equilateral. So negative x squared plus 6 equals 3x squared minus 10. I'm going to add x squared over here, so I get 4x squared with all this. So this is a quadratic. It doesn't have an x value, so the easiest method to solve this quadratic would be using the square root method. So my goal is to get all my x values to the same side and everything else somewhere else. So I get 16 equals 4x squared. I'm going to divide by 4, so I get x squared equals 4. Square root, x equals a positive or negative 2. All right. That's all the notes that are there, but I'm actually going to add something to the bottom here. Okay, so let's say I want to figure out, I have a 5-sided figure here, and I want to figure out how many degrees it is. So one way I can do this is I can take one vertex, and I'm going to draw all the diagonals I can from that one vertex. Okay, this to here would not be a diagonal because they're consecutive. So what essentially you've actually done is you've created 1, 2, 3 triangles. So 3 triangles within this pentagon, 5-sided figure. We should know that a triangle has 180 degrees. So in this case, what I do is I multiply my 3 for the 3 triangles times 180, and I get 540 degrees in this pentagon. Any pentagon will have 540 degrees. So if you also notice, I had 3 triangles made out of that. Well, let's look at a quadrilateral. If I think about this corner, I can do a diagonal here, but I can't do any more. So I have 1, 2 diagonals, so that'd be 2 times 180, which we should also know that a quadrilateral has 360 degrees. But we should see a pattern here. I have a 5-sided figure that has 3 triangles. I have a 4-sided figure that has 2 triangles. That pattern stays. So your number of sides minus 2 times 180 equals number of degrees in the figure. It's always minus 2. 2 less. 2 triangles, 4 sides. 3 triangles, 5 sides. So let's say I had a 10-sided figure, so a decagon, so 10 sides. If I subtract 2, that means that I will get 8 triangles in it. Each of those 8 triangles has 180 degrees. So I do 8 times 180, 1440. So it would have 1,440 degrees in that decagon. Okay? You can also go backwards. Let's say I tell you that there is 540 degrees in a figure. So you would just set that up as 540 equals 180 times some number x. Okay? Well, some number x minus 2, right? If I want the number of sides. So I divide by 180. So 540 divide by 180. So when I divide by 180 on both sides, I get 3 equals x minus 2. Add 2, I get 5 equals x. So it's a 5-sided figure. Okay? Another thing, let's say I have a pentagon again. Any convex figure, if I draw its exterior angles, so an exterior angle is the extension of its sides, but they all kind of fan out the same way. So they go around in a circle like a fan. This plus this plus this plus this plus this always equal 360 degrees. It doesn't matter if it's a 5-sided figure. It doesn't matter if it's a 22-sided figure. Its exterior angles equal 360 degrees. Now, the other cool thing about this is if it's a regular figure, so all sides are equal, all angles are equal, like a square, all of its exterior angles are also equal. So if I extended these, square is probably the easiest one to talk about. If I extended these lines, if this angle is 90, then that makes this angle 90. So those are all 90. So I could just, if I know I have like a regular 10-sided figure, I would just do 360 divided by 10, which would be 36 degrees in each of its exterior angles. Also, let's say that I know that this interior angle here is 40 degrees. Since the exterior angle is made by extending its line, a line is 180 degrees, so this would be 160 degrees right here. Because they have, oops, no, it'd be 140, sorry. Because they have to add to 180. Okay? So that was just some extra info on angles, exterior angles, interior angles, and finding those measurements. Okay, there will be a 1.6 assignment for you guys to complete. After the 1.6 assignment, there is a test review that you guys need to complete in Schoology. And when you get back to class, you guys will have a test over Unit 1.